Hi everyone, in this video, I'm going to discuss a question about momentum. The question seems easy, but it is indeed tricky. No, try once before you decide to surrender, okay? This is a simplified version. So let me read the question. Suppose a ball of 0.6 kg is dropped to the ground. The speed of the ball just before hitting the ground is 10 meters per second, and that just after hitting the ground is also 10 meters per second. The time of impact is 0.1 second. Estimate the magnitude of the average reaction force by the ground. Assume air resistance is negligible. So now you may pause the video and work on it. When you are finished, continue watching the video to check your answer. It's obvious that the rebound of the ball is caused by the reaction force. So first of all, we need to find the change of momentum of the ball so as to find the net force on it. The change of momentum, delta P, equals mv final minus mv initial. Note that momentum and velocity are vector quantities. So when we do the calculation, be careful with the sign. Let's take upwards as positive and downward as negative. So delta P equals the mass of the ball, which is 0.6 kg, times V final, which is positive 10 meters per second as the ball is going upwards after hitting the ground, minus, again, 0.6 kg times V initial, which is negative 10 meters per second because the ball is going downwards before hitting the ground. Now, delta P is found to be 12 kg meter per second. Easy, right? Note that impulse Ft equals the change of momentum delta P. After substituting the time of impact 0.1 second into the equation, we know that F equals 120 kg meter per second squared, or equivalently 120 Newton. So the average reaction force R equals 120 Newton. Done! So easy, where's the tricky point? So now, let's look at the final step. Does R equal to F 120 Newton? What does F stand for? Here, F stands for the net force, or resultant force on the ball. To find the net force, we need to know all forces acting on the ball first. If we draw a free body diagram, there are two forces acting on the ball. The normal reaction force by the ground, R, as well as the weight of the ball, mg, that is mass times acceleration due to gravity. Of course, in a real case, there will be air resistance force or drag force acting on the ball. But in this question, we neglect air resistance. So, as we take upward as positive and downward as negative, the net force on the ball, F, is actually R minus mg. Now, go back to the calculation. Obviously, the last step is wrong. It should be like this. Then, plug in 120 Newton to F, 0.6 kg to M, and 9.81 meters per second squared to G. The correct answer for the reaction force is about 126 Newton. Understand? Alright, don't pretend you don't understand. Let's modify the case from this to this. This time, the ball is sliding on a smooth ground and eventually hits a wall. All the magnitudes of the physical quantities remain the same, like the mass is still 0.6 kg and the time of impact is still 0.1 second, and so on. So, what is the magnitude of the average reaction force Rx by the wall in this case? Okay, same procedure. Let's take rightward as positive. First, find out the change of momentum. Then, the horizontal component of the net force on the ball, as we are only considering the horizontal motion. So far so good, right? Now, the problem is, what is the reaction force Rx? Does it equal to Fx? Let's draw a free body diagram. Of course, there is the reaction force by the wall, the weight of the ball, and the normal reaction by the ground. In the real case, there is also friction between the ball and the ground. But in this problem, the ground surface is smooth, so there is no friction. As we are only interested in the horizontal force, just ignore the vertical forces at this moment. Since rightward is positive, we know that Fx equals positive Rx. In other words, Rx equals 120 Newton. Is that clear? Practice makes perfect. Try this question as a revision. Remember that in an elastic collision, the total momentum and kinetic energy of a system are conserved. Leave your answer as comments. We will show you the answer in the next video. Thanks for watching. Don't forget to like and subscribe.